All right, hello everyone. Your notes for today are going to happen right underneath your launch. So somewhere below your launch, maybe on the next page, create a space for notes. And then go ahead and pause the video to get this first example copied down. So we're going to go through this first example together. This is pretty similar to your launch question. You can see here that we're asked to evaluate a function for a given input. So in order to evaluate f of x plus h, I'm going to go ahead and identify what's inside the parentheses as my input, meaning that's what I'm going to plug in for x into the function to receive some sort of corresponding output, which is the theme for 2.1 so far. So every time I see an x, I'm going to replace that x with x plus h. So here my first x is an x squared. That's going to become x plus h squared. And then minus 2. So we're going to go a little bit further today, as you saw during the launch, and we're going to start to expand out these types of expressions. So we know that this squared here in math means that I'm multiplying x plus h times x plus h. So if I expand, this is called expanding. If I expand this out, it would look like this, and then I still have the minus 2 at the end. Okay. So what I'm going to do now is go ahead and FOIL. I'm going to distribute out this expression. So the first thing I'm going to do is multiply x times x, which is x squared. Then I'm going to go ahead and do my inside terms. So h times x would be hx. Then I'm going to go ahead and multiply my outside terms, which is going to give me another hx. And then finally, the last two terms, h times h, would be h squared minus 2. Okay, so if this step did not make any sense to you, this is called foiling or distributing out an expression. If this doesn't make any sense to you, I encourage you to actually pause this video and search for another video that will walk you through the basics of foiling or distributing, because this is going to be an important skill for class today. So next I see that I have two like terms. I have hx and hx. So I'm going to add them. So I have x squared plus 2hx plus h squared minus 2. Now I'm going to double check my final answer. I want to make sure I have no like terms that I can combine. And it looks like I don't, so that's my final answer. This is the simplest form. So our final answers today are most of the time going to be these long expressions. So I know that f of x plus h, when I evaluate it, it turns into this long expression with all these different variables.